Starting with the graph of f of x equals 5 to the x. So we're starting with this exponential function here. Write the equation of the graph that results from, now we have three transformations. So we'll call that maybe problem 1, problem 2, and problem 3. So this is a review of something earlier in the semester. This is chapter 1, where we covered graph transformations. So somewhere back in chapter 1, I think for us, it was maybe section 5, 1.5, graph transformations. We talked about reflecting, stretching, compressing, and shifting graphs in a way to to generate a graph of a more complicated version of a function by doing something to a simpler version of that same function. Now, in this case, we want to come up with a new function that results from a transformation. So the first one, we're going up by 9 units. The next one, right by 3 units. The next one, reflecting over the y-axis. All right, so let's start with the first one. Now, it's difficult or impossible to do this problem if you're not familiar with these graph transformation techniques. This is not something that I'm teaching in this chapter. This is a review of a few chapters back, but we're applying that to a new type of function. We didn't have exponential functions back then. We do now. So shifting up. Well, we got to go over here to this chart, and I see shifting up c units is a result of f of x plus c. In this case, the c is equal to 9. We're going up 9 units. So if we start with our function f of x is equal to 5 to the power of x, and we want to shift that up by 9 units, we need to add 9 to f of x. Now, there's an equal sign there. So if we add 9 to the left side, we also have to add 9 to the right side. So that gives us f of x plus 9 is equal to 5 to the power of x plus 9. Now we could call that, this f of x plus 9, we could call that something else, g of x, or we could call that y. I'm going to use y because the directions say write the equation. And anytime we're talking about an equation, that's y equals. So I'll use green for my final answer. Let's say y is equal to 5 to the x plus 9. Okay. And that's it. Applying something we've done previously to a function, a type of function that we haven't used transformations on just yet. Okay, next one, shifting f of x right by 3 units. All right, well, looking over here at this table, right. Ooh, I meant to use a highlighter there. Right, c units. Well, in this case, the c is equal to 3, because we're going 3 units to the right. Well, that's a result of f of x minus c. So now the c is inside of the function. So f of x minus 3 is equal to, well, that means we replace the x with an x minus 3. So instead of 5 to the x, it's 5 to the power of x minus 3. And if we're going to write this in the form of an equation, it would be y is equal to 5 to the power of x minus 3. And so if it's a shift in the x direction, the addition or subtraction is in here with the x. If it's a shift in the vertical direction, in the y direction, it's a plus or minus that's separate from the exponential function part. All right, looking good. And finally, find the equation of the graph that results from reflecting over the y-axis. over the y-axis. Now, is that horizontal or vertical? Well, let's see. The y-axis is vertical. Right? This is the y-axis. This is the x-axis. And if we're reflecting over the y-axis, that means we're going left to right. We're reflecting in the horizontal direction. Okay, we're going to reflect the graph of f of x horizontally or over the y-axis. And that happens as a result of evaluating our function f of x at negative x. So f of negative x. So we replace x with negative x. So instead of 5 to the x, we get 5 to the power negative x. And finally, to write this as an equation, let's say y is equal to 5 to the power of negative x. All right? And that should do it for this one. Again, this is not new material. This is a review of something a couple of months back that we can apply to any function. Graph transformations we could apply to any function. In this case, we're applying it to an exponential function. All right, hope this was helpful.